So we've looked at long division with polynomials. We're now going to look at factorizing various polynomials. So this is for cubics and quartics. We're going to use long division so that we can factorize and then of course find our x-intercepts for these equations. So our first step is to start by subbing in factors of 6, or whatever our constant is, into our x values, and we're looking for a result of 0. If we get a result of 0, that means we have found a factor of our polynomial. So here in this instance, if I subbed in -1 for x, I end up getting a result of 0, which means x plus 1, so you've got to flip that sign, is a factor. And we can see that by doing our substitution, and we get 0 remainder, meaning that we can then write this out in factorized form. So we already know that x plus 1 is a factor, and then our result of x squared minus 5x plus 6 goes in our other bracket, and we can continue to factorize from there, giving us x plus 1, x minus 2, and x minus 3. So once again, I'm looking at factors of 6, my constant, plus minus 1, plus minus 2, plus minus 3, plus minus 6. Obviously, starting with 1 or the smaller values is your best bet, as it's a bit easier for substitution, and it's pretty rare that you have to get to 6 in these instances. So yeah, start with 1 and -1. So when we subbed in +1, we get a result of 0, so you can do that there as well. If you want to sub 1 in for x, you'll get a result of 0. That means x minus 1 is a factor. We then start our process of long division. So x cubed divided by x is x squared. This will always match up. We're minusing x squared there. -2x squared plus x squared is going to be -x squared, bringing down our values. So minus x here. Whoops, it's a bit messy. -1 times -x is plus x. So -5x minus x, -6x, bringing down our values. And you can see here we've got everything matching up as we would like, giving us a remainder of 0. So we haven't fully factorized just yet. I might just do that in a different color here. So we would now have x minus 1, and our result of our long division, giving us x minus 1 and x minus 3, x plus 2. Pretty sure that's right. So looking at example 2, bit of a complicated expression this time. You can see here, I'm just showing you that when we sub in -1 for x, we get a result of -38. That means x plus 1 is not a factor of this question. I'm just showcasing that here. But when we sub in +1 for x, we get a result of 0, meaning that x minus 1 is a factor. So that is what we will use for our division of our cubic. So let's get started. Oops, that's a squared. 6x cubed minus 6x squared. So -13x squared plus 6x squared is -7x squared. So minus 7x up here. That's going to be plus 7x there, giving us minus, so 6x minus 6. So plus 6 here. And remainder of 0 as we would like. So now we just need to factorize. Oops, 6x squared minus 7x plus 6. And that's as far as we can go with this question. If we did the discriminant for our quadratic here, it would be less than 0, meaning that there's no solutions for that quadratic part. There would be no further intersections, or our ability to factorize will not work from there. So I'm just going to quickly cover synthetic division here. This is a good way of factorizing the kind of more simple cubics and quartics. But again, I quite like long division just because you're following a process. I feel like it makes a fair bit of sense there. So our 1 out the front here is coming from the fact that x minus 1 is a factor. So we do have to flip that negative sign to a positive. Then my orange text here is simply the coefficients, or the values of each of our terms. So 1, -2, -5, and 6. And here's where we get started. So I do 1 times my factor value, which is 1, and that goes over here. I then do -2 plus 1, which gives us -1. Then -1 times our factor value, 1, which gives us -1 again. and negative 5 plus negative 1 is negative 6. Negative 6 times 1, negative 6, so we bring that across here, and then 6 plus negative 6 is 0. If that does not occur to be 0, it means that you've made a mistake in your working. It's kind of like your remainder there as well. So as you can see, we can then write out our quadratic using our values at the bottom of our synthetic division. So 1x squared minus 1x minus 6. Let's have a go at one of those that's a little bit trickier, as we've got a factor of x plus 2, so we're going to use negative 2 as our working value. So whatever your coefficient is of x cubed goes straight here. We then do negative 2 times 1, which is negative 2, adding these values, so 1 plus negative 2 is negative 1. Negative 2 times negative 1 is positive 2, and so negative 14 plus 2 is negative 12. Negative 12 times negative 2 is 24, and of course we're looking for that 0 there. So now we can say x plus 2, x squared minus x minus 12, and that becomes minus 4 and x plus 3. So it's quite a good quick system to factorize these cubics. I feel like it gets a little tricky as they get more complicated, so I like to use long division, but totally up to you. So this is a bit of a weird part of today's lesson, factorizing polynomials with the rational root theorem. Basically, this is where we get our factors of our constant, in this case negative 3 in the example, and we divide them by our factors of the coefficient of x cubed, in this case 2. So you can see here, if we'd exhausted our factors of negative 3, if none of those gave us a result, we can do that divided by our coefficient of x cubed, which you can see here we get plus or minus 1 over 2, or plus or minus 3 over 2. Pretty confusing. Basically, this is where we've got a situation where we've got something like 2x minus 3, so it's not as simple as what we've been doing in the past. What's a bit strange about this, and the kind of way that the textbook sets it out, is you would use your CAS for this. You would just factorize, or you might use your CAS to calculate that you have a factor of, say, 2x minus 3, which I'll show you in a second. But it's a bit of a weird lesson. You wouldn't really have to do the long factorization, long division by hand for these questions. So looking here, if we tried to sub in our factors of negative 5, so 1, negative 1, 5, negative 5, but we did not get a result of 0, that's where we start trying the rational root theorem. This is where we're looking at factors of negative 5 divided by the coefficient of x cubed, which in this case is 3. So on our CAS, you can see here I've defined the function, and then I've subbed in negative 5 over 3 as our value, and it comes out as a result of 0. So if we do that, we can actually say that our factor, one of our factors, is 3x plus 5. Now this is the bit that I would say you would skip, largely because you just don't have to do it. You would have your CAS already to check this, so it's rare, or pretty much never, would you have to do this long division to actually factorize this by hand. I've seen these questions come up as multi-choice questions or as a kind of part of a bigger problem, so you'd probably have your CAS still for this stuff. But yeah, you need to understand kind of what the rational root theorem is, but not necessarily this long division, which I might even skip right now. So there's the result of our long division in our factorized form. Like I said, it's basically never that you would have to do that by hand. You'd have your CAS to check these, and you would just use factorize. So a bit of a weird situation, but if you want to have a go at that, feel free to do so. So there's a couple of rules here that we can use to factorize various cubics in this form. Pretty tricky. You can see here that we've got these two rules, and the only difference is our subtraction or addition between our cubed and our value. But let's have a look at our first example. So x cubed minus 27, x cubed minus 3 to the power 3, and then we really just input our values. So you can see here we put x minus 3 in our first bracket, and then it's x squared plus 3 times x plus 3 squared, and we can factorize from there. Fairly rare that we have to do that. If you were solving these equations to find the x-intercept, you of course would just make it all equal 0, which would give us x cubed equals 27, and so x equals 3, which we can also see here. So you don't necessarily have to do this a huge amount, but you do need to know this process later down the track. So let's have another go at this. So this is going to give us 2x to the power 3 and 4 over here. So that gives us 2x following our rule above plus 4. 2x here, 2x here, 4 here, and 4 here. And let's do a bit of working out from there. So 4x squared, whoops, minus 8x plus 16. And there's a little bit we can do there. We can actually factorize out a 2 and a 4 here. Giving us 8x plus 2 and x squared minus 2x plus 4. One more of those, but with a subtraction. So 64 x cubed is the same as 4x to the power 3 and 5 over here. So 4x minus 5 following our rule. Hopefully you can see that there. Then 4x squared plus 4x times 5 times, or plus 5 squared. 4x minus 5. 16x squared. 20x and 25, and nothing we can do to factorize further there.